Tonight I want to talk about BACnet, of course, and in particular, we've been working on a project within the BACnet committee to develop some security technology that is based on IT standards to apply to BACnet over IP networks in particular. And we're calling this technology BACnet SC. SC stands for Secure Connect. And what I hope to tell you about is why I think that this is a secure alternative to BACnet IP. Now, of course, everyone has a different idea of what secure means, but it certainly has the potential to be a more secure alternative to BACnet IP. So a little bit about Cimetrics. Probably most of you are familiar with us, but just in case you aren't, we started working on the BACnet standard with many other people in the early 90s, and our first products were released in 95. And as we started selling products to the industry, we saw all this data coming out of building automation systems, just sort of landing on the floor with nobody taking a look at it. So we thought that there might be a business in analyzing the data and helping building owners to run their systems better. So we started doing that in 2000, and BACnet has been an important technology for us in enabling that business. So, in this talk, I want to focus primarily on how BACnet SC differs from BACnet IP. And I assume that many of you here know something about BACnet IP since it's so commonly deployed. But for those of you who might not know too much about it, I'll go through a quick technical review of some of the relevant features. First of all, it uses UDP for communication on TCP/IP networks. UDP is widely used, but as the web has developed, people have migrated to using connection-oriented protocols like TCP and TLS. So, UDP fit how BACnet worked back then, but it's a little bit of an odd duck for the IT people to deal with. But it's worked okay. Another characteristic of BACnet IP, and more generally BACnet, is that you really want to use static network addresses. BACnet standard does not require that, but systems tend to work a lot better if you use static addresses, and in particular on IP networks that need static IP addresses. This is usually fine, but sometimes when you go to the IT department for a new project and you want 1,000 static IP addresses, they look at you like you're a little bit funny. So certainly one of the things that we were trying to do in BACnet SC is to see if we could relax that requirement a little bit. Of course, the advantage of using a static IP address is you don't need a DNS infrastructure at all to make this work. And so with SC, when we relax the requirement about static IP addresses, then DNS comes back to the picture. So there's certainly some pluses and minuses to each approach. BACnet IP was designed to span multiple IP subnets. We use BBMDs, which Jim mentioned a few minutes ago, in order to accomplish that, and I'll show you some examples of that. BBMDs are a good idea, but they're tricky to apply in practice. We didn't imagine all the ways that they could be misapplied when we designed them. We might have done a few things differently, but we are where we are. And of course, NAT. We really weren't thinking about network address translation when we designed BACnet IP, but it's pretty common today. And although we figured out how to make BACnet IP work in a NAT environment, even harder to set up than BBMDs, so it's not something that we ever recommend that anyone try to do. And as for security, BACnet IP doesn't have any native security. So how do people try to secure these networks? Well, VLANs are probably the most common technology for doing that. So you go to your IT department, ask them to set up the routing and switching infrastructure in a particular way so that you can at least isolate the equipment automation devices from other stuff. And if it's set up properly, it can work reasonably well. I think it's a solution that, let's say it's a lot better than nothing. But people are looking for more, certainly. Some people have gone to the extreme of also setting up physically separate BAS networks. I think that's becoming less and less common. Obviously, it's a lot more expensive to do that. And then when you do that, then suddenly you have a challenge of having to manage that network. And that can be even more expensive. So that's where we are with BACnet IP today. So here's a simple network. D1 through D4 are BACnet devices. And you'll see that IP router in the middle of the diagram. That's really where the trouble starts with BACnet IPs. It's because, as I think many of you know, BACnet relies on broadcasts to make it work properly. In particular, if you try to discover other devices on the network, find out where they are, maybe you know, well, my server is device ID 7000. What's its IP address? In order to find that out, BACnet devices use broadcast services. So imagine D1 sending a broadcast. In the absence of the BBMDs, the IP router would block the broadcast, and it wouldn't be able to find devices D3 and D4 over on IP7FB on the right side of the diagram. So the BBMD's purpose is to forward broadcast messages in a way that they'll get through the IP router, and it does that using unicast messages, of course, because IP routers generally allow those through unless they're also acting as firewalls. We also invented the concept of a foreign device. So a foreign device is typically a device hanging out on the subnet which does not have a BBMD. But in order to allow a foreign device to fully participate in a BACnet IP network, we allow it to register with one of the BBMDs in the network. And once it does that registration, then it can fully participate. Now, the BBMDs, I should emphasize, only forward the broadcast messages. So when D5, that forward device in the upper right, wants to locate device D2, it will get some help from BBMD-B and BBMD-A to locate that device through this broadcast forwarding. Now, once D5 has located D2, that is, once it's determined its IP address, then D5 can communicate directly with D2. Of course, they'll have to go through one or more IP routers, more than likely, to get to it, but the BBMDs are now out of the picture. So that's the key point about BBMDs, is they're only involved in forwarding broadcast messages. So we'll keep that in mind when we look at BACnet SC in a couple of minutes. Now, of course, one of the problems with BBMDs and with BACnet IP and BACnet networks in general is that as they get big, then you run into certain problems. And broadcasts are at the root of many of the problems, certainly not all of them. And we've worked with Amy and others on reducing BACnet traffic levels, especially broadcasts, as these systems get big. And you can just imagine, the more devices you have, chances are the more broadcasts that you're going to have in your system. And if if you're only doing IP and high-speed Ethernet, that's probably not a big deal. But we still have a lot of MSTP networks in the world that work at speeds which are, maybe 38K, 56K. And if you have a lot of, especially global broadcasts floating around your network, they can be overwhelming to the MSTP networks and the MSTP devices, and can result in various kinds of performance problems. So in this diagram, we show a network in which we have 6 subnets. I'm not showing any MSTP networks here, but you can imagine MSTP networks coming off of each of these subnets. As this gets bigger and bigger, if every device here sees every broadcast message, we can run into some trouble. So one thing that we did in BACnet IP was to allow you to configure the BBMDs in a different kind of way, so that you could better manage the broadcast traffic in your system. And here's one example of a configuration that you can use to reduce broadcast traffic, especially in the leaf subnets. For example, if you look at subnet A over here, which is served by BBMD A, with this configuration, any broadcasts that originate on subnet D, which is right above subnet A in the diagram, will not be seen by any of the devices on IP subnet A. So for example, if you have a campus and buildings here at Boston University, you might have one or more subnets for each building, and you might decide that, well, this building, this broadcast really only needs to stay within this building and maybe go to the central monitoring system for the campus. And the next door building really doesn't need to see the broadcast from this building. So you could configure your BBMDs in this kind of way in order to reduce the amount of broadcast traffic that devices see that is really irrelevant. And there are a lot of variations that you can do depending on how you want broadcasts to flow in your system. So there's a lot of flexibility here, but the problem is that many of the technicians that actually work on these systems don't understand how to architect this kind of BBMD configuration, and in some cases they don't know how to use the engineering tools in order to accomplish a particular architecture. So we run into a lot of problems with BBMDs, especially in big systems like here at BU. Certainly not exclusive to systems as big as this one. So, does anyone have any questions about this so far, BBMDs broadcasts? Okay, very good. So let's look at NAT for a moment. So NAT stands for Network Address Translation. And if you want to do network address translation in a BACnet IP environment, then you're going to end up with something like this architecture. So you'll see there are 2 IP routers there that are doing network address translation. And let's assume for the moment that they're connected to some sort of a public IP network. It may or may not be the internet. It may just be a campus backbone which contains a mix of traffic. And off to the left, we see that there are 2 BACnet IP subnets. They're both labeled as private networks. So we need to add these things called BBMD routers in order to allow us to bridge the 2 private networks that have BACnet devices on them. Configuring those BBMD routers is a little bit tricky. But in addition, you have to configure the IP router NAT tables correctly. If you get that wrong, then communication isn't going to work very well either. So on the scale of things, this is even harder to configure properly than getting the BDMDs right. So even though the BACnet standard allows this kind of configuration, it's not something that should be, let's say, your preferred option for BACnet IP networks. You do this only when you really have to. There are also security issues here. If there are things that you're worried about that are happening on the public IP network that you don't want to spill into your BACnet network, in particular the two private networks on the left, then you're going to need to configure some firewall rules in your routers. There are just a lot of things that you need to get right to make the communication work and make it safe. So that's probably enough about NAT. What I'm hoping is that you're going to see that the proposed solution we have with BACnet SC solves some of these problems at least. Certainly not all of them. So, what are we trying to do with BACnet SC? Well, first of all, we're trying to do something that's more secure. That will be an alternative for BACnet IP when you need more security. And an important point is that it's designed to work with existing IT security methods. So if you already have VLANs, you can use, or you will be able to use BACnet SC in combination with those VLANs, so you get an extra level of security. If you don't have VLANs right now, if you're running your BACnet devices naked on an unsecured network, then of course I hope you're not doing that. But if you are, then BACnet SC will give you some added security in that situation. Another really important point is that we're not done with this yet. We're still working out some of the minor points of how BACnet SC is going to work. So if you go to some of the vendors here around the table, you're not going to be able to buy BACnet SC products yet. We're hoping that in the latter part of next year, this will be a published part of the BACnet standard. And I'm working very hard with some other members of the working group to get that done. So, some other important characteristics to emphasize. First of all, it's going to be backward compatible with your existing installations. What does this mean? Well, you're going to need some routers to connect BACnet SC networks to other types of networks, BACnet IP or BACnet MSTP. But we haven't changed the basic structure of any of the messages. So, your read properties and your who's and so on will just flow through these routers naturally. BACnet SC is based on standard IT network protocols, WebSockets and TLS in particular. TLS is where we get the security. It is designed to be net firewall friendly. We'll see what that means in a moment. You don't have to use IP addresses that are statically defined, but that does bring DNS into play. And finally, to the relief of many, we're not going to have any more UDP broadcasts or BDMDs. There will be other configuration required, as you'll see, but we hope that it'll be easier to get right in the field. So, what are the security features? First of all, encrypted communications. That's enabled by TLS. Second, site-based authentication of devices, also enabled by TLS. So what does this mean? So let's say you're BU and you have vendors putting devices on networks that you control. Right now, if I had physical access to the MSTP network in this building, I could hook up an MSTP device and start talking back into all the other Siemens controllers in this building. With BACnet SC, that won't be possible unless the building owner wants to run a really lax network. So how is this going to be accomplished? You'll be using site-specific certificates that will be installed in each of the BACnet SC devices. And that will allow the other devices in the network to determine whether this device is part of the system or not. So you need to have the right kind of certificate in order to join the network. So I won't be able to just plug into the BACnet Explorer or something and peek around in the network unless I have the right kind of certificate installed in my PC that's running BACnet Explorer. We've thought about how to implement certificate revocation too. I'm not going to go into much detail, but if you have questions about it, I'll try to answer them. But the idea there is if somebody steals a BACnet SC device off the wall, you want to be able to kick out that device from your network and also kick out its certificate so that if someone manages to yank the certificate out of that device and put it in another device, you want to make sure that that new device won't be able to join the network, assuming that you detected that the device was stolen. And the third capability, which is a new thing that is being added to the specification right now, is the possibility that BACnet SC can be used to carry authorization information. So authorization is a little different. Let's say that you have a particularly sensitive piece of equipment, and you want to limit the users that can either read data from that piece of equipment or more likely change some parameter in that piece of equipment. So ideally, you want to have some way of controlling access to that equipment. And the working group has decided that BACnet SC will allow you to insert into the BACnet SC package authorization information. And this is a little bit of a complicated topic. It would probably deserve its own speech, about 30 minutes, just to talk about how that would work in practice. But we don't expect that everyone's going to want to do this, but we want to have that capability there so that the customers that are the most paranoid will be able to implement some sort of restrictions on who can do what to what devices. So let's talk about the architecture of BACnet SC networks. A key part of any BACnet SC network is what we call a hub. And you can think of a hub as being a little bit similar to a BBMP in that it relays all broadcast messages between devices, but a hub has a lot more capabilities than just relaying broadcast messages. It can also relay messages that are from one device to another specific device in the network. So how does this work? Each of the BACnet devices in a BACnet SC network are required to make a connection using TLS and WebSockets to the primary hub. Once they've made that connection and have been authenticated by the hub, then they're allowed to send messages through that hub, either broadcast messages or messages to other specific devices. Now, for performance reasons and for reliability reasons, we wanted to also enable peer-to-peer communication between devices. Now, this is not a requirement for every device. If you have a BACnet SC light fixture, you might not bother to implement peer-to-peer capability in it. But for more sophisticated devices, you probably would. So any of these BACnet SC devices, once they've been authenticated to the hub, they can then go up and make connections to other BACnet SC devices and check their certificates on both ways to make sure that they're allowed to talk to each other. So this should improve performance, especially in big systems. As well, we decided that one hub was probably not enough for some customers. They're going to want to have some redundancy. And since the hub has such a central role in BACnet SC networks, we've added failover hubs or secondary hubs to the architecture. So the idea here is that devices connect to the primary hub, but if it goes down for some reason, devices will then connect to the secondary or failover hub, and communication will be able to continue as before. Now, you probably remember from the diagrams about BACnet IP that BBMDs have to reside on networks that have other BACnet IP devices in order to be able to forward messages on behalf of those devices. One of the differences with BACnet SC is that the BACnet SC hubs no longer have to reside on an IP subnet that has any BACnet SC devices at all. In fact, you could put those hubs in Amazon Web Services, Amazon's cloud, Google's cloud, your private cloud, your customer's private cloud. As long as the devices can make a connection to the hubs could be anywhere that is convenient for you. So this adds a considerable amount of architectural flexibility that I know people want. I was just at a conference at Princeton, attended by large universities, and one of the complaints they had about BBMDs, one of many, I should say, is that they were pretty restricted as to where they put BBMDs. What they really want to do in some cases is to put BBMDs in, for example, IT-managed server closets, maybe even in data centers. And that just doesn't work. But with BACnet SC, you'll be able to do that. You have a lot more flexibility. Okay, let me show you a few scenarios, and then we'll wrap things up here. Here's a really simple BACnet SC deployment scenario in which you're running on an unsecured network. Maybe it's one like here at BU in which students have free access to it. In this case, you might put the primary and failover hub on the same unsecured network as well as your BACnet SC devices, and everything should talk to each other if they have the right certificates. So this is the most basic, but one can imagine some more complicated scenarios. For example, this one in which you have a BACnet operator station that's connected to the internet somewhere, and it can connect to and communicate with devices that are behind the facility firewall. Let's say in this case, BACnet IP devices. So the idea here is we have a BACnet router, that's that rectangular thing inside the facility. And that router goes between BACnet SC and BACnet IP. And the SC part of the router is making a connection outbound through the firewall to the primary BACnet SC hub, which in this case is connected to the internet somehow. As well, the operator workstation has made a connection to that same primary hub. And that might be behind the firewall as well, although that's not shown in this particular diagram. But Once they have both connected to the hub and their certificates have been checked, now that BACnet operator workstation can communicate through the BACnet router to the legacy BACnet IP devices in that facility. So this gives you an idea of the kind of architectural flexibility that you can have, and this is, of course, without using a remote desktop or anything like that, which not everyone likes. Okay, so here is another, perhaps more complicated scenario. In this scenario, we still have a bunch of legacy devices, IP devices, MSTP devices within the facility, and we also have the primary and failover hubs, both within the facility, behind the facility's firewall. If you have another laptop, like the one that's connected to the internet, on the far left of the diagram, it could also potentially connect into this network, although it's a little trickier to set up because now that laptop, its communication has to traverse through the facility's firewall, which will probably involve some other security methods, in order to get to the primary hub. Once it gets to the primary hub and makes that connection and certificates are checked, then it will have access to the network, just like the laptop that is within the facility boundary. So this is a scenario in which perhaps an institution like BU might want to manage its own hubs within its own infrastructure, but yet allow remote access on some selected basis to, let's say, vendors that need access to their equipment in order to do service. So there are a bunch of other scenarios that we can talk about, but I'm running low on time here, so I'm going to wrap up quickly. If you want to learn more about BACnet SC, there isn't that much information published yet since we don't have an approved standard, but that white paper is a good introduction. I took several of the diagrams in my presentation from the white paper. It is current as of this summer. We're still making some tweaks to BACnet SC, and those are not reflected in the white paper, although I assume that we'll update it at some point next year. Also, if you're planning to go to ASHRAE, there's going to be a session at the conference on securing BACnet networks. It's going to include a presentation on BACnet SC, but also some information on other methods for securing BACnet systems. And the speakers are all very good. So, takeaways. BACnet SC will be at least a more secure alternative to BACnet. It's intended to complement other security methods that IT departments or facilities departments might implement to increase the levels of security. But of course, security comes at a cost, and not everyone's going to want to use it because you have to maintain infrastructure in order to manage certificates, among other things. If anyone's interested, we can talk about some of the details of that offline. But we think that we have something here that will be easier to configure than BPMDs, and yet provide almost all the same functionality with a high level of security. So, thank you all for your attention.
Security questions for Jim.
So you're using one cert for the whole site? Is that?
Now, the idea is to have a device, each device have its own certificate, but that certificate would be signed by a certificate authority, which would be managed either by the IT department of the site or by the primary controls vendor if the site doesn't want the responsibility to make that. If you don't have individual device certificates, then you can't do individual device revocation.
Yep.
Jim, what was the viewpoint of the committee in the design as to who would be responsible for maintaining this over time? Do most controls vendors think they have the capability to do this?
I think that controls vendors that service the smaller and mid-sized jobs will have to have the capability to act as a certificate authority and manage their certificates. And I assume that this would be a capability that would be built into their engineering tools. But for the larger sites, we definitely see the end customer is managing the certificates. If you go to a place like BU, I'm sure that their IT departments might want to handle that themselves using their own policies. So we have to accommodate both scenarios.
On that, the last topology slide you had up there, forgive me if this is a little nuts and bolts simple, but if I were to take my operator laptop and plug in, say, on that unsecure BACnet IP ring you've got, would I still be able to see the entire network, including the SC devices? Is that the nature of having an unsecure leg?
Yes,
Okay.
that's true. So, BACnet SC only secures the SC part of the network, right? So I could, in the scenario I mentioned before, for example, I could still find that thermostat that Siemens installed, and if it's an MSTP thermostat, I could plug in my MSTP device and I'd have access to the entire network. So this is not fixing the security issues around non-SC devices and components of the system. It's an excellent question.
So yeah, I think that was really good. So I guess the answer is for those that want to have a fully secure network, going with a fully 100% BACnet SC system would be the way to go.
That's correct.
Hey Jim, your three little round devices on the bottom there of the ring, they have the red data path, which is secure, and they have the little black path, which is not. Do they have to have the black path, or can they just live on the red one?
The black path is sort of a physical connection.
Got it.
And the dashed orange lines are a logical connection to the primary hub. So,
Right.
Yeah, they have both of them.
But philosophically, can you actually get to that secure device without being a registered device yourself? Or is that one safe because it only talks secure anyway? You can't get to it.
Well, those devices only talk BACnet SC.
Okay.
But there are routers in the system. So if you're a BACnet IP device, let's say.
Those routers are going to route everything. They're not selective.
Absolutely.
Gotcha.
If it's
Okay.
a standard BACnet router, it will allow the BACnet
Okay.
IP devices free access to BACnet SC devices. This is one of the motivations for using authorization in your system.
Okay.
You might decide as a policy that none of the BACnet IP devices are allowed to change any parameter in any BACnet SC device. And you could enforce that using a combination of BACnet SC and OAuth 2, for example.